Hello, this is the Python coder, and we're going to look at data structures and how to use them. So we start off with the dictionary we looked at before, which is like a label or a key and value. So in our example we saw before, we had a dictionary called scores, and we had the person's name as the key, the label, and their actual score as the value. We can print them using a for loop. So we have for x and y in scores.items. So the items has the key and the value. So we print the key and the value as x and y. If we just want to print the keys, that will just be the names in the scores example. We can do that using .keys. And if, for example, we just wanted to print the values, we can just use .values and print them. The dictionary is not ordered, so if we want to print them in order, we can use the sorted word and use the scores.items. So that way we can print the dictionary in the order of keys, the key order. Okay, let's have a look at counting some items. Here's a list of letters. We have some A's, some B's, a C and an F. Using a dictionary and the get function, we can count those letters. If you try to access something in a dictionary that's not there, it might crash your program. But if you use the .get function, if it's not in the dictionary, so if you're looking for an item that's not there, then the get will give it a default value. So in this example, we make the default value 0. So when we're counting letters, the first time we count them, it gives it the value 0. Now we want to count them one time, so we use the +1. Now once a letter is already in the dictionary, we want to retrieve that value and add 1 to it. That's what counting is. So here we have the dictionary, we have the for loop to go through the list of letters, and the dictionary will count how many times those letters occur. So when we print that, we have A occurred 3 times, B 3 times, letter F once, and letter C once. So that's the count dictionary. An alternative way is to use a counter from the collections module. So here we have a for loop, the same with the letters, but we count them using the counter. So here we've got the same answer, but it's a different data structure. We've mentioned sets before. One way that we can use a set is to remove duplicate items from a list. So here we've got a list called my list. We change it to a set, so therefore sets don't have duplicates. And if we want to change it back to a list, we can do that. So in this example, the unique list is exactly that, a unique list from my list. So my list is a list, changed to a set, and then back to a list. So that's a way of using set to remove duplicate items. We mentioned tuples. Here we have a tuple called my tuple, 1, 2, 3, 4. We can just use commas without any brackets, and that will create a tuple. If you want to use brackets, you can use the round brackets to create a tuple. Now tuples don't really do much that we can't do with a list, but they are stored in a way that's quite efficient. So if you want any temporary variables that are more than 1, you can use a tuple. So for example, when we printed our dictionary using items, we have 2 items, so we use x and y. That was a tuple. So here's an example of a dictionary with the keys 1, 7 and 3 and the values high, no and by. And we can create a tuple from the items. So the tuple of 2 items is going to be 1 and high, 7 and no, and 3 and by. We can sort our tuple using .sort, and then when we print that, you can see the output here. We have a list of tuples. The tuples have 2 values. They have the number, like 1, 3 and 7, and the string high, by and null. So here's the output. It's a list, but each element in the list is a tuple. Other data structures we mentioned before were queues and stacks, which we know from real life. A queue, people line up in a queue at the ATM, for example, and then once they've finished, they leave off the front and people join the queue at the back. Whereas a stack, such as like a stack of books, we put things on top, and if we take them off, we have to take them off from the top again. So if we want something from the bottom, we have to take them all off. So we saw the stack in the last video where we looked at how we could solve the maze, and we put in the left was wrong, so we popped that, and then right, and then left was the correct answer, and then we exited the maze. So we could just use a list because we're only putting things at the end and taking them off. So you can use, for example, .pop, or if you want to be more involved, there's a way of creating different functions that you can pop and push. So for example, this web page will show you the class stack and has several functions, which inside a class will be members, and then you can implement that and push and pop and print them. So if you want to look at that example, there's a website. We haven't really covered that area yet. It's just to show you other ways. Remember when we had a queue that didn't work for the maze because it was the wrong left? With a queue, we want to leave from the front, but we can't do that with a list, can we? So when you remove the first item, the rest will move up one. So in this example, 1 has gone, and now we move 2, 3, 4 and 5 forwards. So how would you implement that? That's going to be quite expensive if you move everything in a list. So as always, someone's already wrote the code before. So for example, there's code using DQ, so you can import DQ. So just for example, from collections import DQ, we have a queue, and then we can add items using append, and then we can remove items from the front using pop left. So there are other ways of implementing queues. Here's just one. We also mentioned trees and graphs. So here was the tree that we showed, had A, and that had children B and C. C had a child F, and D and E were both children of B. So we could write that in a dictionary. Here we've got a dictionary called tree parent, and here every node in the tree is the key and the value is their parent. So the parent of B and C is A, the parent of D is B, as is the parent of E, and F has the parent C. So you could store other things using these keys. So here we have a dictionary tree scores, and we have the nodes in the tree and their scores. We mentioned graphs. So we can't use a dictionary because a graph, we don't have children. Yeah, and we don't have one parent. So a graph, you could use something like a two-dimensional list. So here we've got a two-dimensional list called neighbor, and the neighbor of A is B, and the neighbor of A is D. Neighbor of B is D. A neighbor of B is E, and a neighbor of C is D. Now, for things like trees and graphs, maybe it'd be better to use objects. So we haven't covered them, but that's coming soon. Okay, thank you for watching, and if you haven't already, please subscribe, and if you like the video, give us a thumbs up. Okay, thank you for now. Bye.